Hello, I'm internship from National Tsinghua University. In this project titled Efficient 3D Indoor Scene Generation via LLM-Controlled Infinigen and Blender MCP agents, we reduced the total time to create a fully furnished room from about an hour to just 10 minutes, and we did it without requiring the user to write or edit any code. Realistic 3D indoor scenes are becoming increasingly important in fields like game development, virtual reality, and robot simulation. However, current generation methods still face a few major challenges. It often takes a long time to produce a complete scene. Making even small adjustments usually means digging into complicated code, which is not friendly for non-technical users. Some solutions also require expensive hardware and yet still produce repetitive designs. These difficulties motivate us to rethink the entire workflow from scratch. Our pipeline fully automates the entire process in 4 stages. The user simply types a natural language prompt into a gradual interface. A large language model then converts that prompt into a structured YAML constraint file. Infinigen reads the YAML and generates a basic floor plan in Blender format. Finally, an intelligent agent running inside Blender places furniture throughout the scene. The whole process can be summarized as prompt in, furnished room out. The frontend captures free-form user requirements such as the number of rooms, size preference, and style choices. The language model parses these inputs into structured parameters and saves them into a YAML file. Infinigen takes this YAML and uses a probabilistic grammar system combined with Mondrian style subdivision to build the basic structure, including walls, doors, and corridors. Blender MCP then loads this shell, and inside Blender, the ST-MCP agent, guided by Claude Sonnet's language model step-by-step reasoning, places each object carefully while checking for collisions and orientation rules. The agent refines the scene until all layout constraints are satisfied. 3 main components enable our system to work this efficiently in object generation. ST-MCP allows the agent to think and refine step by step, much like a human designer would. Blender MCP offers a high-level socket API, which simplifies the control of Blender without writing fragile low-level scripts. Claude 3.7 Sonnet's language model provides deep, large context reasoning, helping the system create layouts that are both collision-free and visually coherent. In terms of performance, our system is able to generate a fully furnished photorealistic apartment scene in about 10 minutes. This represents an 83% reduction in generation time compared to traditional methods, without sacrificing the quality or realism of the final scene. The first demonstration clip shows how the frontend works. After the user enters a prompt, a large language model and Infinigen work together to generate a floor plan Blender file. The entire process from prompt to floor plan takes less than 2 minutes. The second clip demonstrates the furnishing stage. Claude Sonnet, working through Blender MCP and Sequential Thinking MCP, places every furniture items you see, from sofas and televisions to floor lamps, bookshelves, coffee tables, and rugs. The agent continuously audits its own work through chain-of-thought reasoning, adjusting each item's position and orientation until all spatial and stylistic constraints are satisfied. Looking forward, we have 3 main goals. First, we plan to expand from single-room layouts to full multi-room apartments. Second, we aim to add automatic material and lighting optimization to ensure a consistent visual style throughout the scene. Third, we will explore using multiple specialized agents working together, with different agents focusing on furniture, decor, and physical simulations respectively. Thanks for your listening.